Let's look at the solution of algebra bytes. If the value of log 2 to the base 2 by 3 plus log 2 square by 3 to the base 2 by 3 plus log 2 cube by 3 square to the base 2 by 3 and so on up until 20 terms is equal to x plus 20 times of log y to the base 2 by 3, where x and y are positive integers. Find the value of x plus y. Okay. First thing we need to do is write all of it down. Log 2 plus log 2 square by 3 raised to the power 1. So I can write here 3 raised power 0 and 2 raised power 1 plus log of 2 cube by 3 square plus log of 2 raised to the power 4 by 3 cube, so on and so forth up until the 20th term. The 20th term itself would be log 2 raised to the power 20 by 3 raised to the power 19. Now log a plus log b is equal to log ab. So I have to multiply each of these terms. I would get log 2 raised to the power 1 plus 2 plus 3 plus so on and so forth up until 20 by 3, 0 plus 1 plus 2, so on and so forth up until 19, or this would be equal to log of 2 raised to the power 210, the power would be 210 by 3 raised to the power 190. Okay. So far you would have noticed I have not written down the base anywhere, because up until this point, the processing did not really need the base. But now that we have it, the final form requires me to have a constant term, an integer constant term, and then something with this form. So the constant term that I can get, can I break this down term as log of 2 raised to the power 190 by 3 raised to the power 190, 2 by 3 into 2 raised to the power 20, which will break into 190 comes to the outside. These terms I will separate, but because they're multiplied, now they will be added up. 190 times of log of 2 by 3, 2 by 3 plus 20 times of log 2 to the base 2 by 3, which happily tells me, now see, this portion is 1. So I finally have 190 plus 2 times of log 2 by 3. Sorry, not 2, 20. This is 20. 20 times of this. Now when you compare it to the original expression, x is equal to 190, y is equal to 2. Finally, we needed x plus y. So answer to this question will be 192. Next, when Anuj substitutes x equal to 1 in the expression, ax cube minus 2x plus c, its value is 5. Okay, let's substitute x equal to 1. I would get a minus 2 plus c is equal to minus 5, or a plus c is equal to minus 3. We've got this. When he substitutes x equal to 4, the expression has a value of 52. So 64a minus 8 plus c is equal to 52, or 64a plus c is equal to 60. From the first equation to the second equation, a has increased by 63 and the constant portion has also increased by 63, which gives me a is equal to 1. If a is equal to 1, c should be equal to minus 4. So the expression we are dealing with is x cube minus 2x minus 4 is equal to 0. Finally, we are asked one of the values of x that makes the expression equal to 0 is. Basically, we have to find one of the roots here. The good thing here is it is a cubic and we have 4 options available. We simply have to plug in values. Even when you're plugging in values, hopefully if you're paying attention, these numbers are even This 0 is even. So x itself has to be even. X cube has to be even. So the only two possible choices are 0 and 2. 0 wouldn't work because for 0, if x was equal to 0, I would get -4 equal to 0, which is not possible. So the only case that works is 2, where you would get 8 minus 4 minus 4. Yes, this is indeed equal to 0. So answer to the question is option B, 2. Next question. It is given that a and b are roots of the equation x square minus 13x plus m is equal to 0. Okay, so we have a plus b is equal to 13, and b and c are roots of the equation x square minus 15x plus n is equal to 0. So c plus b is equal to 15. If a, b, c are in arithmetic progression, find the value of n minus m. So what we have is a, b, c. If they are in arithmetic progression, this is b minus d, and this is b plus d. This is b minus d and b plus d. So if I replace these terms, I would get 2b minus d is equal to 13, and 2b plus d is equal to 15. So the second equation minus the first equation gives me 2d is equal to 2, or d is equal to 1, or if d is equal to 1, c, which was b plus d, I would now have 2b plus 1 is equal to 15, or b is equal to 7. So this is 7, this is 8, this is 6. Finally, we are asked value of n minus m. N is equal to AB, and m is equal, sorry, n is in the second equation, no? So it is equal to BC, and m is equal to AB. So n minus m would be equal to b times of c minus a. So b is 7, c minus a is 2, 8 minus 6. So the final answer we get here is 14. Next question. A generous man set aside a certain sum of money for equal distribution among a certain number of persons. If there are 5 fewer persons, then each will receive $2 more. And if there are 4 more persons, each will receive $1 less. How much did each person receive when there were 4 more persons? Okay. So I'm saying let each person receive R, and there are n persons. So the total amount with the generous man is this. And this is also equal to if there were 5 fewer persons. So then each would receive $2 more. So R plus 2 into n minus 5. Okay. So what do we have? Let's check. If I open it up, I get Rn plus 2n minus 5R minus 10 is equal to Rn, or 2n minus 5R is equal to 10. This is the first equation. In the second setup, if there were 4 more persons, so Rn is equal to n plus 4, then each would receive $1 less, R minus 1. So this opens up to nr plus 4R minus n minus 4, or 4R minus n is equal to 4. We have these two equations. We can happily solve for both these cases, or we can solve for both these variables. So let me just multiply the second one by 2. I'd get 2 here, not 2, 4R, no, sorry. I'd get 8 here, I'd get 2 here, and I'd get 8 here. Now I can happily remove n from consideration. If I simply add these two up, I would get 3R is equal to 18, or R is equal to 6. The amount that everybody was receiving in the original situation was 6. But the final question was, How much did each person receive when there were 4 more persons? When there were 4 more persons, each received R minus 1, or they received $5 each. Okay. Next, find the product of the roots of the equation x square plus 19x plus 99 is equal to 2 times of under root x square plus 19x plus 102. The first step here has to be whatever portion is here under root, let us take that as m square. Let's say m square was equal to x square plus 19x plus 102. What that would do is the equation will now change to m square minus 3 is equal to 2m. Bring it to the other side. M square minus 2m minus 3 is equal to how much? 0. So m square minus 3m plus m minus 3 is equal to 0. M taken out common, I get m minus 3 plus 1, m minus 3, or m is equal to minus 1 or 3. Now see this m portion, or given that we are looking for m portion is within this under root portion, So this is not really possible. It has to be equal to 3 only. If this has to be equal to 3 only, then let's work. If m is equal to 3, so m square will be equal to 9. If m square is equal to 9, what we have is x square plus 19x plus 93 is equal to 0. Now the product of the roots of the equation will simply be equal to 93. Why it will not be minus 1 is, see, if you plugged in minus 1, if you plugged in m is equal to minus 1, then the problem that would happen with this is that, let me just confirm. Okay. What is the problem with this? If m is equal to why it is cannot be minus 1? I now see this is under root m square. So the result that we get here has to be a positive number only. We cannot get a negative number. This is a positive root. So when we are getting minus 1, this is not possible. Therefore, the answer to this question has to be 93. That will be all for this episode. Hopefully you learned something.